Hey everyone, ready for another deep dive? Today we're going deep into the world of AI, but not just any AI. We're talking about large language models that can hear, like actually understand what you're saying.
Yeah, it's pretty wild. It used to be all about text, but now AI is starting to interact with the world through sound.
Like it's developing its own sense of hearing.
Exactly.
And the star of our deep dive today is this research paper. It's called Soundwave. Less is more for speech-text alignment in LLMs. And this paper describes a new LLM that's getting a lot of attention. And you know what? It's all because it can understand speech using way less data than other models.
It really is remarkable. You see, Soundwave only needs 10,000 hours of data, and it gets results that are as good as models trained on 500,000 hours. That's a huge difference.
That's mind-blowing. Like learning a language in just a few weeks compared to years.
A perfect analogy.
So today what we want to do is kind of pull back the curtain on Soundwave. How does it actually work? What all can it do? And why is this whole data efficiency thing such a big deal for the future of speech-capable AI?
Great questions. And to answer them, we need to start with the most basic challenge. How do you get an LLM, which is basically designed to deal with text, right? How do you get it to actually hear and understand spoken language? Which is a totally different beast.
Yeah, that seems like a big hurdle. I mean, speech is messy, right? It's continuous with all these variations in tone and pace and accents. It's not neat and tidy like written text is.
Exactly. And for a long time, researchers tried to solve this by using massive data sets of labeled speech. They just threw tons of data at the problem.
Kind of a brute force approach.
Yeah, but Soundwave takes a totally different route. It's much more efficient. It uses this three-phase training strategy that's almost like a dance. Each stage builds on the last one.
Oh, a dance metaphor. Tell me more about these stages.
All right, so the first stage is all about alignment. You got to get the speech and text representations into the same space. So it's kind of like teaching the LLM a whole new language. It has to understand that these sound patterns mean certain words or concepts.
So it's like learning that cat, the sound of the word cat, means the same thing as the written letters C-A-T.
Exactly. And then stage two, well, that's shrinking. Imagine taking a giant audio file and making it way smaller without losing any of the important stuff. This is where Soundwave's data efficiency really shines. It figures out which audio features are crucial and keeps those and throws away the rest.
So it's not just chopping out random chunks of audio. It's more like writing a really good summary that still gets the main points across.
Another great analogy. And then finally, we have stage three, supervised fine-tuning. This is where Soundwave really starts to learn how to do specific tasks. It gets instructions in both text and spoken form.
So it's like boot camp for the LLM, taking those basic skills and honing them for the real world. But I'm still kind of stuck on this shrinking thing. Like, how does it actually shrink the data without losing the meaning? Can you break that down a bit more?
Sure. Remember how in stage one it learned to connect speech and text? Well, Soundwave uses that connection to figure out which audio features are actually important for meaning, and then it throws away the ones that aren't doing much, so you end up with this smaller but still really powerful data set.
Wow. And to think it does all of that with way less data than other models? I'm already impressed. And we haven't even talked about what it can actually do yet.
Right. What stands out to you the most about how Soundwave is designed?
Honestly, it's the efficiency. It just blows my mind. 10,000 hours versus 500,000. I mean, come on. It just seems like they really put a premium on flexibility too, right? Like those adapters they talked about in the paper. They kind of remind me of Lego bricks for building LLMs.
Haha, you're spot on. Adapters are these small modular pieces that connect different parts of the system, like the part that processes audio with the part that understands language. They're super important for making training efficient and for adapting to different kinds of tasks.
So it's like having a toolkit that you can easily swap out parts for different jobs.
That's a great way to put it. This whole modularity thing is really crucial for LLMs if we want them to become truly versatile.
Yeah, that makes a lot of sense. So besides these adapters, are there any other cool techniques they use? I know they mentioned things like CPC loss and dynamic data mixture and temperature sampling. We can go into those more later on if you want.
Oh, definitely. But first, let's talk about what Soundwave can actually do. It's time for the results.
Okay, spill the beans. What are Soundwave superpowers?
Well, they put it through its paces with this benchmark called AirBench. It's designed specifically to see how well LLMs understand speech and sound. Think of it like the Olympics for LLMs.
Okay, so how does Soundwave do? Did it take home the gold?
It did even better than that. Soundwave actually beat a lot of existing models on this benchmark, even though it was trained on way less data.
Wow. That's a real underdog story. Okay, I'm hooked. Tell me what Soundwave can do.
Well, of course it can do all the basic stuff like transcribing speech and translating between languages. But what really makes Soundwave special is its ability to do zero-shot translation.
Wait, zero-shot translation, you mean it can translate between languages it's never even seen before? That sounds like science fiction.
Yep, that's exactly what it means. It really shows how deeply Soundwave understands language itself. Like it's figured out the underlying connections between sounds and meaning across different languages. Just imagine what we could do with that.
I am imagining it. Real-time communication between people from different cultures, breaking down language barriers for global teamwork, or even helping out in disaster zones where people speak different languages. It's mind-blowing.
It really is. And Soundwave doesn't stop there. It can even recognize emotions in speech, tell the difference between different sounds like a dog barking and a car horn, and even figure out what the speaker's trying to do.
So it's not just about understanding the words themselves, it's about getting the nuances, the emotions, the intent behind what's being said. You mentioned some of the cool techniques that make Soundwave work earlier. I'd love to hear more about those, especially that CTC loss thing. It sounds like technical, but I think our listeners can handle it.
Sure. CTC loss stands for Connectionist Temporal Classification, and it basically helps align sequences that are different lengths. Remember we were talking about how speech is processed frame by frame, but text is broken down into words or subword units?
Right, that inherent difference in how audio and text are structured.
Exactly. CTC loss helps bridge that gap. It teaches the model to connect sounds to text even when they don't line up perfectly in time. It's like trying to transcribe someone who talks really fast. Their words kind of blur together, so it's hard to tell where one word ends and the next one begins. CTC loss helps Soundwave deal with that.
So it's like teaching the model to read messy handwriting.
Haha, yeah, kind of. Now let's talk about dynamic data mixture. It's all about giving the LLM a balanced diet of data.
Making sure it gets all its nutrients.
Exactly. Soundwave learns from a mix of speech, text, and all sorts of sounds. And dynamic data mixture makes sure it learns from each type of data effectively. It's like having a personal trainer who designs a workout that targets all your muscle groups.
Got it. Okay, last one, temperature sampling. Does that have to do with keeping the model from overheating? I'm just kidding. But seriously, what does it do?
It's all about controlling how much the model explores during training. Sometimes it needs to stick to the rules, and other times it needs to try new things and experiment. Temperature sampling helps find the right balance.
So it's like giving the LLM a little bit of freedom to improvise, but still making sure it learns the fundamentals.
You got it. All of these techniques, together with Soundwave's overall design, they really show a shift in AI research towards building models that are more efficient and adaptable. But I want to circle back to zero-shot translation for a second. It seems like that's the thing that's really capturing people's imaginations. What do you think is so fascinating about it?
Well, to me, it suggests that Soundwave isn't just memorizing translations. It's actually learning something deeper about the nature of language itself.
That's a really important point. It's like Soundwave is building this universal language representation in its mind. It's figuring out how to capture the core meaning of a phrase, no matter what language it's in.
So it's almost like discovering this hidden language of meaning that underlies all communication, both spoken and written. That's incredible. Does this mean that we don't need traditional translation methods anymore?
Not so fast. Zero-shot translation is still pretty new. It has huge potential, but we still need human experts for those really nuanced and specialized translations. Think of it like having different tools in your toolbox. Sometimes you need a hammer and sometimes you need a scalpel.
Okay, that makes sense. It's about using the right tool for the job. And it's important to remember that no AI is perfect. Were there any areas where Soundwave didn't do so well?
That's a great question. And yeah, there were a couple of things. For example, it wasn't as good at identifying different languages, probably because most of its training data was in English.
Ah, so it has a bit of an accent.
Haha, you could say that. But if it had more data in other languages, it would probably get better. It just shows how important data diversity is if we want AI to be truly versatile and fair.
Totally. And it highlights the importance of responsible AI development.
Another interesting thing was that Soundwave wasn't that much better at basic speech recognition tasks, like transcribing audio to text, compared to more complex tasks like understanding intent or emotion. That was kind of surprising.
Yeah, you'd think basic transcription would be easy for an LLM like this.
Right. It might be because those traditional speech recognition systems have been fine-tuned for those specific tasks, using way more data. Soundwave, of its focus on efficiency and generalization, might not have had the same level of training for those specific things.
So it's like a trade-off then, like being a jack of all trades versus a master of one.
That's a great way to put it. And which approach is better really depends on what you want to use the model for. But even if it's not setting any speed records for transcription, it's clear that Soundwave is a big step forward for AI, especially with its ability to learn new things and handle those more nuanced human-like tasks.
It makes you wonder what's next for AI research. If Soundwave can do so much with so little data, what does that say about the potential for AI to learn from the real world in a really efficient way? It's an exciting time to be following this field.
It really is, and that sense of excitement and wonder is what we hope to share with our listeners. But Soundwave's capabilities also point to some bigger trends in how AI is being developed.
Like what?
Well, we've been talking about how efficient Soundwave is with data, right? And it's not just Soundwave, it's like a whole trend in AI.
Right.
Researchers are trying to build models that can learn from less data and use what they've learned in new situations and interact with the world in all sorts of ways, like through text and speech and images and who knows what else.
It's like AI is becoming more well-rounded, more like us.
Yeah, it's pretty crazy when you think about it. Makes you wonder what it really means to be intelligent, doesn't it? But maybe that's a topic for another deep dive.
Good point. Let's stick with what we know for now. So we've been talking about all the cool things Soundwave can do, but we should also talk about the potential downsides, right? I mean, any technology this powerful could be misused. Did the researchers talk about that at all?
They did, and it's a conversation we need to be having as AI becomes more and more part of our lives. They stressed the importance of being responsible with this technology, especially when it comes to preventing misuse.
What kind of misuse are we talking about here? Can you give us some examples?
Well, imagine someone creating these super realistic deepfakes using someone else's voice without their permission. Or think about targeted audio messages that are designed to manipulate people's emotions or beliefs. It's kind of scary when you think about it.
Yeah, it's like audio could become a weapon in the wrong hand.
Exactly. We need to be thinking about ethics and safeguards as we develop and use these powerful AI tools.
It sounds like something out of a sci-fi movie, but this is real life. It makes you realize that the future of AI isn't set in stone. It's something we're creating right now with the choices we make.
That's a really important point. It's not just about the technology itself. It's about how we use it and what values we build into it. We have to make sure that AI is used for good and that everyone benefits from it.
It sounds like we need a global conversation about AI ethics, something that involves everyone, researchers, policymakers, and the public, to make sure these advancements are used responsibly.
I completely agree. We need to be talking to each other and working together if we want to navigate this new world in a smart and ethical way.
This has been quite a journey. We've gone from the nitty-gritty details of how Soundwave works to the big philosophical questions about what it means for AI to be more and more like us. It's been amazing.
I hope you're feeling that same sense of awe and excitement about the future of AI. It's a field that's constantly changing and full of surprises. There's so much potential.
It's definitely given me a lot to think about. To everyone listening, thanks for joining us on this deep dive into the world of Soundwave. I hope you learned something new and that you're as excited about the possibilities of AI as we are. Keep asking those questions, stay curious, and let's keep exploring the amazing world of human ingenuity together.